Hello again, and today this is the last but not least talk, and it is my pleasure to introduce you my colleague and friend, Dr. Maria Escribá, that is coming from Equipo Juana Crespo in Valencia, Spain. And she's going to talk about the 3PN embryos. Maria, whenever you want, the floor is yours.
Thank you. So, hello everybody, my name is Maria Escribá, and I'm one of the embryologists in Equipo Juana Crespo in Spain. Okay. First of all, I would like to thank Vitrolife for inviting me to speak about our study that we are currently running in our clinic in cooperation with the genomics. Okay. Today I talk about 3PN embryos and how to manage them in an IVL lab on a routine basis. As we know, in an IVF lab, fertilization, we confirm the fertilization around 17 hours after conventional IVF or ESHRE. Okay. We know that an egg is correctly fertilized when we observe two pronuclei and the extraction of the second polar body. This is what we know that we call as a 2PN embryo. Sometimes we observe a third PN, and we know that the egg is it's uncorrectly fertilized, and we call to this egg 3PN embryo. Okay. 3PN embryos are commonly discarded due to the suspected risk of being triploid or having an extra set of chromosomes. So the question is, do all zygotes with free observed pronuclei or 3PN embryos have an actual triploid chromosomal complement? In 2017, Capalbo et al. Proposed a new way to look at these 3PN embryos. They divided them into two groups according to the size of the third pronucleus, and they only analyze the embryos where they have two similar PNs of similar size, and the extra one was a smaller ones, believing that these might have a better prognosis. They even transfer these embryos, and in result they have two healthy babies, proving that viable embryos could be rescued from this pool of 3PN embryos. Recently, Genomics has launched a Smart PATA Plus, which is a PATA Plus with several advantages. It's a full-in-one test that has two extra quality control as cohort check and contamination detection. It uses a combination of NGS with AI algorithms to enhance the detection of aneuploidies. And in addition, Smart PATA Plus has a SNPs analysis to determine the ploidy of the embryos. So this will allow us to biopsy 1PN, 2PN, or 3PN embryos, classifying them as haploid, diploid, or triploid embryos according to the number of chromosome sets. Another benefit of Smart PATA Plus is that it doesn't require parental samples. So in a simple way, we can biopsy embryos that otherwise they would have been discarded. So knowing that some embryos can be viable from this PPM pool, and now having this new technique, we started with this study to compare both types of 3PN embryos. Those where all pronuclei are similar in size, and the other group is the one where two pronuclei are similar in size, and the third one is a smaller one. We wanted to compare them to see if they behave in a similar or in a different way. So now here in ESHRE we have this poster, okay, with the data of the 3PNs collected up to January 2024. But to give better evidence of our findings, we are still collecting 3PNs as we want to increase the number of 3PNs analyzed. So today I'll give you an updated version of our research that includes the data of 198 3PN embryos from 185 cycles involving 180 patients, that all of them consented to participate in the study. The study is ongoing in our lab in Equipo Juana Crespo. It's located in Valencia, in Spain. And the 188 3PNs were observed between June 2023 and April 2024. During that period, our 3PN incidence was 1.9% of all fertilized embryos. So the first thing we did was to define both types of 3PNs. The first group is the microtriploid, or the commonly known as 2.1 embryos, where the diameter of the smallest pronucleus is less than 70% of the diameter of the largest pronucleus. Okay, this is an example of a 2PN embryo, where we see at the right the small PN. Yeah. Okay. These 2.1 embryos might be difficult to identify. So according to our experience, with embryoscope, it's much easier to spot this small PN. As sometimes you have dark or granular areas where it's difficult to spot. Or sometimes, like in this example, at the time of the fertilization check, the small PN hides behind a large PN, so it's difficult to spot it. But with the embryoscope, moving forward or backwards, you will see it eventually. In addition, with embryoscope, for an study, you have more robust data. The second group are the pure triploid, or the PT group, where the diameter of the smallest prenucleus is more than 70% of the diameter of the largest prenucleus. This is an example of a typical pure triploid, and these ones are very easy to identify. Okay, so we'll start with the results. From the 198 free PNs observed, 89 were 2 PN embryos and 109 were PT embryos. All of them, both groups, the 2.1 and the PT, were cultured until blastocyst stage, and as a result, we have 72 good quality blastocysts. We define good quality blastocysts as good enough blastocysts that are suitable for freezing after a potential transfer after analysis. Sorry. Okay. Out of 89 2.1 embryos, 34 reached the blastocyst stage, and out of 109 in the PT group, 38 reached the blastocyst stage, resulting in 38.2 of blastocyst rate for the 2.1 group and 34.9% for the PT group. Not significant differences were found between both rates, but both rates were significantly lower than the blastocyst rate for their sibling 2PN embryos found on those 185 cycles, which was 58.3%. All 72 blastocysts were biopsied, and 60 of them were informative for ploidy and aploidy status, 30 for the 2.1 group and 30 for the PT group. We have very interesting results of the ploidy status of the embryo, as 27 out of the 30 blastocysts in the 2.1 group were diploid, and only 3 were triploid. As 0 in none of the embryos in the PT group were diploid, and all of them confirmed to be triploid. So the diploid rate is 90% for the 2.1 group versus 0% in the PT group. We are fully aware that 60 cases may not be enough to draw strong conclusions in a PhD program, especially due to the heterogeneous dispersion of the age of our patients. So to simplify this, what we wanted to do here was to compare the euploidy rate of our overall 3 PNs with the euploidy rate of our overall 2 PNs biopsy during 2023. What is important here is to observe that not only that a euploid population among 3 PNs not only exists, but is also similar to the 2 PN group. And we're sure that we will reach a more solid conclusion as the number of 3 PNs biopsied increases. Finally, we have the rates for the viable embryos in each group. For the 2.1 group, out of the 30 embryos, 27 were diploid, and out of these 27, we have 10 viable embryos for transfer. Despite having euploid embryos in the PT group, as none of them were diploid, there were no available embryos for transfer for patients. So 33.3, or a third, of the 2.1 biopsied embryos are viable embryos for transfer for patient. So as a take-home messages, we can say that it's very important to differentiate the two types of the 3 PNs, because they will help us to know the potential of the embryo and advising the patient in the best way. Most of the 2PN the 2.1 free PNs are diploid, 90%, so it is worth to biopsy and analyze them using PAT+. because with this technology, they will inform us about the ploidy and the euploid status of the embryo. Despite most of them being diploid, the remaining 10% of 2-point embryos are truly triploid. So we cannot transfer them without a previous analysis, as they could result in miscarriages or triplet pregnancy or molar pregnancy. Regardless being triploid or diploid, embryos could be still euploid, mosaic, or aneuploid. So with PET+, we will know if they are suitable for transfer. A third of the 2.1 biopsy blastocysts are viable embryos, increasing the number of viable embryos available for the patient for transfer. So as a conclusion, we can say that despite having a lower blastocyst rate than 2PN embryos, micro 3PNs or 2.1 embryos are worth to be kept and analyzed. It's very important to be analyzed, as they are very likely to be diploid and their euploid rate is similar to 2PN embryos, increasing the number of transferable embryos as a benefit for patients. And thank you very much.
Thank you very much, Maria. Congratulations for fantastic presentation.
Thank you.
There's any question on the audience? Come on, don't be shy. So I've got one question. Do you think that this kind of test is going to be the standard of care in the near future at the clinics? Because we will have more embryos to transfer, but also avoiding transferring euploid embryos that are triploid or haploid, right?
Yeah. My opinion, 100%. But not only for triploid, even for 1PN, 3PNs, both types of 3PNs, even a 4PN or 5, because it's very easy with this test. It's just a routine analysis, a routine biopsy on blastocyst stage, and you will get the results, and you can give an extra embryo for the patient. And I think it's especially important for this patient with low reserve, with that all patients, that the number of embryos are very important for them. So an extra embryo is always a very good news.
Yeah, we know that. Okay, so if you don't have any more questions here?
Hi, so nice presentation.
Thank you.
I'm Jorge Gomez from Finland. Do you see like any difference between like the rates between ICSI and conventional IVF?
No, we haven't seen. We have all this data is collected from ICSI, as they are in Embryoscope, and we are just collecting the data from Embryoscope. But we wanted to be them on time labs to have more robust conclusions, and then we will see even the kinetic parameters of the embryo. So they are in time labs from the beginning. So we have only ICSI for this.
So
sorry.
All this data is from ICSI?
It's from ICSI, yes.
More questions? Okay, so thank you very much again, Maria. Fantastic presentation.
Thank you.
And see you all tomorrow on the second day of the Vitrolife Group Academy Studio. Thank you.